Hi class, this is course 3, lesson 16, irrational numbers. So just when you thought that we were about done learning about numbers, we're going to throw more types of numbers at you. So this is the entire set of real numbers. We started with counting numbers, then worked our way up to whole numbers, integers, and rational numbers. Remember, rational numbers are all of the above, integers, whole numbers, counting numbers. It's any number that can be written as a fraction, it's a terminating, or a repeating decimal. Well, now we're going to talk about irrational numbers. So those are everything that rational numbers are not. They are non-repeating or non-terminating decimals. They are non-perfect square roots. And we just talked about square roots in lesson 15. It's also a number that is unable to be written as a fraction. Okay, so non-perfect square roots is where we're going to focus today. We will talk about non-repeating or non-terminating decimals specifically in the future, but non-perfect square roots, if you use a calculator, you'll get a decimal approximation, but that's not the exact square root. So make sure that if it's a non-perfect square root, and what's a perfect square root or a cube root would be like those examples we did the other day. Square root of 25 would not be an irrational number because that ends up being 5. So these can be kind of tricky, but let's talk about a couple examples. So let's make sure that you have this written down in your notes, and then let's look at a couple examples. So if I asked you which one of these were irrational, we're going to categorize a couple of these. We're going to do irrational, yes or no. The square root of 9, is that irrational? Well, the square root of 9 is what? Well, it's 3. So is it irrational? No, it's not irrational. Well, what about the square root of 7? Well, what is the square root of 7? Is it a perfect square? Yeah, if you do this, I have no idea what the square root of 7 is, then it's probably irrational. In this case, you know that the square root of 9 is 3, and the square root of 4 is 2. So is there another perfect square that's that makes up 7? 2 times 2 is 4, 3 times 3 is 9. There's no other whole number in between there, is there? So that's one indicator that you're talking about an irrational number. It's not a perfect square. So that's one of the things that you'll be asked to do. Determine if they're irrational or rational. So irrational means it's not a perfect square. Now, if you use the calculator, and when you get a calculator, if you need some assistance looking up how to plug in the square root function, let me know. But what you'll be asked to do in the book is to put this number on a number line. So if we had numbers like 1, -2, 1/2, maybe the square root of 4, square root of 7, put those on a number line. So we draw a number line, and we're going to put 0 here, and let's see, 1, 2, let's call that -2, and we'll go 1, 2, 3, 4, 5, right? 1, 2, 3, 4 will come by 2s. Okay, so now remember, when you plot these on a number line, you actually put dots, points on the number line. So where is 1? 1 is right here. That's 1. Where is -2? -2 is right here, and it's already labeled for us. Where is 1/2? That would be right here. 1/2. Where is the square root of 4? Well, we know that better as 2, so we're going to put a point on 2. And where is the square root of 7? Well, we just identified that it's between the numbers 2 and 3. Now, do we know how close it is to 2 and how close it is to 3? Not really. Not without using a calculator. But if you put it right here and say the square root of 7 That's close for an approximation. Okay. So that's kind of what you'll be asked to do. Put them or arrange them in order from least to greatest, or plot them on a number line. One other thing that you'll be asked to do, and we did this at the end of lesson 15, is if you're given a square and they tell you the area equals, let's say the area equals 5 square centimeters. They want you to determine the side length. The side length equals what? Well, remember that the formula for area of a square is area equals side squared. So we don't know our side lengths, right? But we know that it's 5 centimeters squared for our area. So again, we undo, because we know that this problem is 5 centimeters squared now equals side squared. See that? I just substituted this for this, 5. I know that A equals 5 centimeters squared, so I'm going to plug that in. I'm going to substitute that. Then it's the square root. To solve this, I need to use the square root. That's the inverse of squaring. So my answer would be square root of 5, and then I know I can square root centimeters squared. That's just going to be the length, centimeters. So not always will we have nice numbers anymore. Okay, these are irrational numbers. Now this is most accurate. Okay, square root of 5 is a definite length. We can measure that. But we can't get a decimal approximation. We can't get accurate with decimals, because that decimal is going to go on and on and on and on forever. So unless you're asked to round to the nearest hundredth or something like that, leave it the irrational number square root of 5 in the radical form. Okay, so again, if you have questions about anything here, please let me know. Otherwise, I will see you in class.